Hello, ladies and gentlemen. Today we are talking about the absolute value function. Now, we've talked about absolute value functions before, but here's a whole section about it. So if you want to dig into the book and really see all the ins and outs of it, chapter 3, section 6 would be the place to go. And you're welcome to do that if you like. But here's the gist of it. All right, here, you remember that we were doing those function transformations? Well, we can do all of that with absolute value functions, just like with quadratics, just like with polynomials, just like with linear equations, whatever kind of equation it is, the same transformations work. And I've got them listed up here. And so just to kind of make some comments on this, we saw that things could happen in the x direction or in the y direction. And it's real easy to shift it up and down by adding or subtracting a number to the result of the function. We can apply a vertical stretch, um, which would take a quadratic that looks like this, and it would make it go up faster so that it seems to stretch it upwards like that. We can apply a vertical reflection by changing, putting a negative sign. Instead of going up, it would go down. And all of that happens outside of the function itself. Here's the function, and we add something after we're done. Here's the function, and we multiply it after the function's been evaluated. Here's the function, and we put in a negative sign in front of it, which flips it upside down. Okay. We also had all the changes in the x direction. I can shift it left or right. So for a quadratic like this, if I come in here and say, I don't know, minus, let's say it says -8 or something like that, that's going to shift the whole thing to the right 8 spaces. Okay. And, if the sign stays negative, then I have a negative here. And remember, it kind of seems to work backwards. If there's a negative number, it shifts it to the right. Positive number, it would shift it to the left. That is inside the function. Inside before I evaluate the function, I add or subtract a number right there. Now I can certainly do both, right? If I had a -h here, then it would shift it left and this guy would shift it up or down. So that's okay. Things can happen in both directions at the same time. I can apply a horizontal stretch by multiplying by number before I evaluate that function, and I can do a horizontal reflection across the x-axis. So if I had, a function that was doing, I don't know, maybe this, and I put the negative x in, then it's going to reflect it. But notice again, that is inside before I evaluate the function. So that's kind of the trick on those. Let's try some of that with the absolute value function here. Here is kind of the general form of the absolute value function. You can see the absolute value bars there, so you know that's what you're dealing with. And you can see that we have modified it, or there are some possibilities to modify that thing here. That K on the end is going to shift the whole thing up and down. This H right here, I'll just put vertical shift right there. The H is the horizontal shift, left, right. That B inside, before I take the absolute value of the function, would be the horizontal stretch. And then outside here, I could do a vertical stretch. So all of that is possible. Maybe it's easiest just to kind of see it in action. And I do have here the, where's my, here we go. What do I got to do right there? So with the, oh, I lost my screen. Where is it? Let's try that one. Okay. I've got some simulations here. I've been kind of building this list as you go. So this is a good place to go. This is up on my little website. And all you have to do, of course, is type in PWR physics. and or there's a link in the in D2L, either one. Um, but just a PWR physics should get you there. And first thing that comes up should be that. I've already had it pulled up, but if you did a Google search, it should be, I don't know. We've talked about this. Uh, what? Yeah, there's a Google search, right? So it's just right there, a little Google site. It's got all my stuff in it. Go down to the math information, college algebra, math 110, and there's all those simulations that we've seen. I've already got a couple of these pulled up. Here are a whole bunch of them. So if you want to play with these things and say, oh, here's my square root function, use the little sliders to apply a vertical shift, a horizontal shift, whatever. Those are all there. But we're talking about absolute value transformations. There is one of those. So I'll put that up here, and you can see those sliders that I'm talking about. Unfortunately, they called it ABCD instead of ABHK. We're just going to have to deal with that. They were kind enough to put the formula here so we can see exactly what they've done. And that D, for example, would be at the end. We're adding, subtracting a number. That's going to be our vertical shift. And right there, you can see that we're shifting that thing up and down. That's all it does, moves it straight up and down. Over here, you have the function itself. So right now, the one and the one don't really do anything. We're multiplying those, so you can kind of ignore it. That is an absolute value of x plus 2.5. You can see that the whole thing's been shifted up 2.5 spaces. I could go down to negative 2.5. Somewhere down there. Okay. And all it would do is change the sign out in front of that. So that's that vertical shift at work there. A is out front, and that's going to be my vertical stretch. Let's play with that for a second. Again, this one is outside, so it's going to be a Y direction. As I move that, see how it's growing faster? I'm stretching it in the Y direction. It's going up faster than it was before, or I could come down here and it could be much slower. So it's kind of like somebody stepped on it, mashed it flat. And if I keep going, the negative there would be that reflection across the x-axis. So that negative sign just crept in right there. I'll take it back out for a second. Boop. There's a positive number. So I've got the absolute value going up. As soon as I drag it down into negative land, then it inverts it, it reflects it across a that y-axis. I mean that bottom point right there, and off it goes. So that's all the stuff that is outside of the function. We added something that shifted it up and down. We changed the number outside after we took the absolute value. That is the function at play here, and that changed the slope, how fast it went up or down or reflected it or whatever. Inside, I could change those numbers as well. And like you see right there, C is that horizontal shift. And so when I drag C right there, you can see I can slide the whole thing left. I can slide it right. When I'm looking, let's put it back in the middle right there. So in the function itself, there is no plus 3, minus 2. There's no thing after the x. So here it's straight up absolute value of x. It is shifted down. We can fix that real quick. But by simply dragging C, here I have a positive 2.1, and you can see that it shifted at 2.1 spaces to the left right there. If it's plus, it goes left. And if I drag it over here like that, now I'm horizontally shifting that thing to the right, but that's got a negative sign in there. So that left right appears to work backwards. What's really at play here is you have a negative sign from the formula, and then your shift is here the shift is positive. So that negative in the formula and the positive, negative times a positive is a negative. You end up with a negative there. If I have a um, a shift this way, then I've got the negative from the formula, and the negative shift would give me a a positive right there. Negative times a negative be a positive. Just kind of remember it goes backwards. Um, then the other thing we can do is the horizontal stretch, which is factor B right there. So as I move that one, you can see it kind of does two things there. One, it works something like the vertical stretch where it does make it steeper or less steep. I can't invert it, but see what it's doing is it's also moving the vertex, which which the vertical shift did not do. Oops, I got to grab B instead of A. See how the vertex, the bottom point stays the same there, but not for B. So that's kind of a difference there. Not quite the same thing, but they both make it skinnier or fatter there, make it grow faster or slower. Okay. So those are kind of fun to play with. And again, I invite you to go grab those. They're all linked up there in the website. Um, and then maybe that helps. Anyway, let's go back to this page where we had the problem, and I'll just make up something here. If we were graphing this by hand, and I had something like, well, I don't know, let's make up a function f of x equals 3 times the absolute value of 2x minus 4, close absolute value plus 3. Okay. And I want to graph this thing. Then we can do several things here. The first and probably the easiest thing is to just build a little table like we've always done. Pick some numbers, put them in here for X, and see what we get for Y. All right. If I do that, if I put in a 0, then 2 times 0 is 0, so that will go away. I've got that -4. I take the absolute value of -4 and get a +4. Multiply that by 3 would be +12. Add 3, and now I've got a 15. Okay, so I'm way up here off of the chart. Probably not a good number to pick, but you can see that I'm up there somewhere. Let's try something else. Let's try a 2. Okay. If I put a 2 in here, 2 times 2 would be 4. Subtract 4, you got 0. The absolute value of 0 is 0. Multiply by 3, still 0. Add 3, you got yourself a 3. So there's kind of a point that fits on the thing right there. And what we want to do is just pick a couple numbers and see what we get. Let's try the next one. 3 here. 2 times 3 is 6, minus 4 is 2, times 3 is 6, plus 3 is 9. Boom, we're off the chart again. So that wasn't necessarily a good one to pick. However, you can already get a feel for what's happening. It's up high, it comes down low, goes back up high again. And so we need to pick something that's and I put that point in the wrong place, didn't I? 1, 2. That should have been right here, not over there. But I'll erase that other one here. Okay. Um, so we're kind of doing something like that. All right. That +3 means that it got shifted up, so the whole thing never gets down here to the x-axis. And I don't think we could try some other numbers and see, but we're going to need to come in real close to 2. So maybe this wasn't the best of examples. I am going to pull up the calculator and put this in. Of course, that's always option number 2. You got the thing in your hand or your pocket or somewhere. I can go 2. Absolute value is on the math menu. So I hit math button. I go over to number ABS right there is the absolute value. Inside there, I want a 2x minus 4. And then I want to add 3 to the whole thing to shift it up. And when I draw the graph, we're going to get something like that, which is, what we were starting to see there. We just didn't quite have enough room on that thing. They're getting a 1, 7, 3. That would be 6 minus 4 is 2, 6, 9. Yeah. Wonder if my scale is zoom standard here and make sure. Huh. 1, 2, 3, 4, 5. Looks like that'd be about a 6. When I put a 1 in there, 2 times 1 would be 2, minus 4 would be -2. -2, the absolute value would be positive. 2 times 3 would be 6, plus 3 is 9. So either their scale is a little bit different and I'm missing it, or 1 is also 9. Okay. But that does tell me that the bottom is there at 2, 3. If you wanted to get some more points, you could either come in here on your table thing. You can say second, hit the graph button, and see in yellow it's got the table. And so right there is a list of the points that it's plotting right there. And I think you can come in down here. Let's see. And there's, it keeps going. So maybe that wasn't the best of options. That 3 kind of made it grow really, really fast. And I probably should have left that off or made it smaller or something. All right. But you can always build a table. You can go to the graph on your calculator and and see exactly what that thing is doing. Okay. With the other thing that they might ask you to do is, of course, to find the intercepts. That last one didn't have any intercepts because it didn't get down to the x-axis. But here's one right here. And, we could draw the graph and either with a table or with the calculator. I'll do it with the calculator because we've already seen how much fun it is to do with the, by table. It works. It's not hard. But absolute value 4x plus 1, we can already see that's going to shift it to the left, right? Because there's a positive there. And then we're going to shift the whole thing down 7 spaces. By the time we shift it down 7 spaces, it ought to cross the x-axis somewhere. And there is what we're looking at right there. All right. So if we could zoom in a little bit there, I think we would see that it's down 7, it's over 1 to the left, and it's growing 4 times faster than it normally would right there to give you that. So I'm going to just kind of sketch that in here. I don't know if that's a good sketch or not, but you get the idea down there, right? They wanted us to find the intercepts here. Where are these 2 points where it crosses the x-axis? We've got loads of practice doing this, but I'll put this one here with the thing. There is my function. I want to set that equal to 0. I want to get this x by itself. So all of this is kind of locked up inside the absolute value, and that -7 is hanging off by itself. So this would be a perfect place to come in here and move the 7 so as to cancel it off of the left. And then, of course, I've got absolute value of 4x plus 1 equals 7. And now I can see there are 2 possibilities. Either the stuff inside the absolute value started out as positive, so all of that stuff inside was equal to +7, or maybe all of this stuff in here started out being negative, and the absolute value bars took the negative number away, but I need to get inside there and see what's happening inside absolute value. So take the stuff inside and set that equal to the negative possibility. I need the +7. All that could have been positive. I need the -7. All this stuff in here could have been a -7, and the absolute value bars chopped it down to a +7. Okay. From here, real easy to solve. You'd subtract 1. So 4x equals 7 minus 1 would be 6, and x would be 6/4 or 1.5. Over here, I would subtract 1 again. -7 minus 1 is going to be -8, and I divide by 4. -8 divided by 4 would be -2. So there's the two places that we expect this thing to cross at. You can see that it crosses right there at somewhere right between 1 and 2. So 1.5 makes sense. And then meanwhile, I got to go 1, 2, -2 spaces, 2 spaces to the left to get the other intercept right there. So that's I think everything there is to know about absolute value. You can always build a table. You can always go to your calculator. Um, you can see how those function transformations will move it around, stretch it, kick it up, flip it upside down, whatever. And I don't know anything else to say about absolute value bars, so I will be done with that. But thanks for stopping by. Bring your questions and we'll figure it out. Thanks.